In this presentation, we're going to look at continuous random variables. Now, there's a couple of new things in this that we're going to look at. The random variable x has PDF, probability density function f of x, given by the following expression here. F of x equals kx squared times 1 minus x. The range of values that x is valid for, or that we have a PDF for, is essentially between 0 and 1. Okay. Show that k is equal to 12. Okay, so this is very standard stuff to begin with. The total area under the PDF, under the curve basically, is 1 when you integrate it between 0 and 1. So the upper and lower limits there are L and U, or U and L, and they are 0 and 1 in this case. So essentially what we have to do here is just integrate the PDF, probability density function, between the upper and lower limits, and that should equal to 1. Okay. Now, in this case, we're told explicitly what the upper and lower limits are, but in other questions, you might have to figure them out. So, kx squared times 1 minus x. So, essentially, what I'm going to do is rearrange that mathematically as k times x squared minus x cubed. And what I'll do actually is I'll take the k out of it just put it out there. Okay, just to make it a little bit easier. So, what we end up with is x squared minus x cubed. When we integrate that, what we end up with is x cubed over 3 minus x to the power of 4 over 4. And what we do is that's a definite integral to be evaluated between 1 and 0, or 0 and 1. Okay. So just calculating that out. So I do this different ways in each in different presentations, but essentially what I really want to get across there is just actually check that if you evaluate it at 0, does it come out at 0? Okay. Now, as it turns out, that whole thing goes to 0 in this particular presentation, in this particular example, so we don't have to worry about it, but you could get trapped there, you could get tricked, so be careful. So what we end up with is k times 1/3 minus 1/4. Okay. And when we simplify that, we get 1 over 12. So k over 12 is equal to 1. Necessarily, k is equal to 12. So that's the first question done. Okay. So show that the mode of x is at 2/3, x equals 2 over 3, and draw a graph of x. Okay. What I'm going to do here is actually I'm going to draw a graph of x first. Really, these type of questions don't really come up anymore. Or drawing graphs. Not so much. Maybe a very simple example. Okay, this will probably be very complicated for an exam. So that's 0, that's 1. Okay, essentially what you do there is you might pick a few values, 0.2, 0.4, 0.6, and 0.8, and then just figure out what the heights are, and then just connect them all up. Okay, just draw a little curve to fit them all. Okay, that's how you would sort of do it very quickly. So it's pen and paper stuff. Now, what we're looking for is the maximum value, or the highest point of the curve, which is up here. So that's our mode. Essentially, the mode is the value of x where that occurs. Okay? So this is what we're looking for here. And it's between 0.6 and 0.8. So it should be around, judging by that graph, 2/3 or 0.66. So essentially what we are doing here, this is differentiation, and this is applications of differentiation. Find the maximum and the minimum. So essentially, looking at the curve there, this is at the maximum point. This is the type of thing you probably learned when you learned about differentiation. So what we're doing is differentiating the PDF. Okay. And what we end up with there is our PDF is 12x squared minus 12x cubed. When we differentiate that, we get 24x minus 36x cubed. Okay, and what we do is let that equal to 0. Okay, now I'm going to give you the short answer here. So x is either equal to 0 or x is equal to this. Also, we divide by 12 because it's trivial. Okay, just divide that whole thing by 12 without any loss of information. So it's 0 for 2 minus 3x equals 0. Therefore, x is equal to 2/3. Now, judging by the graph, there's a solution to that. X equal to 0 is actually a solution to that expression there, but we know that's not what we're looking for. Judging by the curve, we know that this is not the maximum. Okay, we know the maximum is up here, so we can discount that one. Okay, the trivial solution. So just ignore that basically. Make a little statement about it just to sort of clarify that we know x is not equal to 0. It's not useful here. Okay. Now, you can do this if you want. Actually, you probably should just go for 100% in an exam situation. It depends on how much time you have. So just to check that that is the maximum, get the second derivative with respect to 0 and check that whatever you get is negative. Okay, when you evaluate it at x equals to 2/3. The second derivative is this value, is this expression here, 24 minus 72x. And that's clearly going to be less than 0 where at x is equal to 2/3. So essentially, we're home and dry now. We've got it all sorted. We've covered every eventuality. Now, I'm going to go through this very fast because basically I've done a lot of these elsewhere. And essentially, so I'm just sort of going over it again. This is the key formula that you have to remember, that one there, okay? Oops, my pen's stuck. Anyway, so that's the key thing that you have to sort of use there to answer this, okay? So you should know that one off by heart, okay? So the key thing you're integrating here is x times f of x, okay? So it's a definite integral, and it sort of more or less follows the same sort of track. We have 12x cubed minus 12x to the power of 4. When we integrate the expressions, taking the 12 out of it, we get x over 4 divided by 4 minus x over 5 divided by 5. The definite integrals so essentially what we're doing is evaluating it at 1 and 0 and getting the difference. And again, just watch out that that is equal to 0. So working it through there, we get our answer is equal to 3 over 5. So I'll just sort of scrub all that out there, and you can have a quick check of that, and you see that the answer there should be 3 over 5. Okay, so we have to get the variance as well. So an intermediate step is we have to get the expected value of x squared. It's done the same way. Okay, essentially what we're doing is integrating that, which turns into this expression here. 12 times x to the power of 4 minus 12 times x to the power of 5. This is the key part there, evaluated at 1 and evaluated at 0. Okay, and what we should do is find that it ends up as 12 over 30, or in other words, 2 over 5. So, I've gone too far there. So the last part is, just to wrap it up, you should know this as well. This is very important. It will probably pop up somewhere in this exam, or any exam that you have in this sort of stuff. The formula that you would use. So essentially express the difference between the expected value of x squared and the square of the expected value of x. Okay, two different numbers there, two different terms. They're both different to each other. So we found that one is equal to 2 over 5 and the other is equal to 3 over 5. 3 over 5 squared is 9 over 25. 2 over 5 can be written as 10 over 25, and therefore the variance of x is 1 over 25. Now, just as a remark, we're going to remark that the standard deviation of that, which we're going to be using shortly, is the square root of that, which is 1 over 5. So, find the cumulative distribution function of x and obtain the probability that x lies within one standard deviation. Okay. Now, this is actually the fundamentals on which the first part of the question is based on. So this is the theoretical fundamentals, that the cumulative distribution function is the integral from 0 to x, or actually the lowest possible value of x, which we know to be 0, okay, up to x for the PDF, where the PDF is expressed as in terms of a different temporary letter. So we're using u just to sort of just to make it different for just for the time being, and then we integrate it with using x and then so on. Okay, so that we end up with an expression in x is what I'm going for basically. So 12u squared minus u cubed, or in brackets, so evaluate that, and so essentially what we do here, sorry, that should be x. So essentially our integrals are x and the lowest possible value of the range of numbers, okay, the lower limit, Okay, in this case it's 0. Working that out, we should get, I mean, this is work using the same sort of calculations we've done in the first part. Here we're substituting x into the expression, so we end up with x cubed over 3 minus x to the power of 4 over 4. And what we end up with here is 4x cubed minus 3x to the power of 4. Actually, what I have done here below is I have gone one step further. I've called that x cubed times 4 minus 3x. Okay, which is what we're going to be using later on. Okay, now don't forget to put stuff like that in with these sort of questions there. Okay, so just I could have put it spelled it out a little bit more, but you have to put that stuff in beside this. Just express the correct range of values where of x that for what this expression is valid for. Okay. Now, one standard deviation of its mean. Okay. What does that mean? Well, we know that the mean, the expected value of x, is 3 over 5, and we know that the standard deviation is 1 over 5. Okay. Well, we weren't told it exactly. There was a bit of guile there come into that. But essentially, this is the expression that we're asked to compute. 2 over 5, the probability of x being between 2 over 5 and 4 over 5. So essentially what we have to do here is evaluate this expression here. Let's just write it out the way I wrote it out there. X cubed times 4 minus 3x. Okay. It just makes the mental arithmetic a little bit easier, actually, for me anyway. And so just to get the difference between the two. Okay. So this expression here can be written as that. The cumulative distribution of, sorry, that's the CDF there. Not the PDF, the cumulative distribution function. And it's the difference between the two CDFs. 4 over 5, the cumulative distribution of 4 over 5 minus the cumulative distribution of 2 over 5. So essentially, just working that out, x cubed there is x cubed in both cases is 4 over 5 to be cubed and 2 over 5 cubed, and times 4 minus 3x, and that works out to be 8 over 5 and 14 over 5 in both cases. So what we end up with here is for 4 over 5, the cumulative distribution function works out to be 4 over 5 cubed times 8 over 5. And for 2 over 5, it's 2 over 5 cubed times 14 over 5. Essentially what we got here is a bit of calculator work. So it should be straightforward enough to simplify. And there we have it there. The answer should work out to be 16 over 25. The 7 there is just the page number. You can disregard that.